I hope you all have seen these digital clocks in railway platforms or in airports. Well, these digital clocks show the arrival and departure timings of trains or flights. Now, the timings shown by these digital clocks are in accordance with the local time of a particular region. So, what is meant by local time? See, in this picture, the three friends are having a quarrel over the local time of their current location. One says that it's 11:59 am. The other one says that it's 12 noon. The third person says that it is 1 minute past 12 pm. Now, why do you think there is a confusion with the local time? Also note that the sun is overhead a particular longitude, that is longitude x. Now, do you think is there any relation between the sun's position and the local time of a place? Yes, there is a direct connection between the local time of a place and the position of the sun. This is because the local time of a place is defined as the time based on the longitude when the sun is overhead on that particular longitude. The local time of a place is generally 12 noon, and that is the time when the sun is overhead over that particular longitude. If the sun would have been overhead over longitude y, then the local time of this place would have been 12 noon instead of 12:01 pm. Again, if the sun would have been at this position, that is overhead longitude z, then the local time of this place would have been 12 noon instead of 11:59 am. So, we find that the local time of a place is usually 12 noon, and it is a time when the sun is overhead over that particular longitude. So, all places lying on that longitude has 12 noon. Also, we can understand from this picture that the local time of all the places on the earth are not uniform. This is because the sun cannot be overhead over all the longitudes at the same time. So, when the sun is overhead over a particular longitude, then the local time of that place is 12 noon. So, local time of different places vary according to the position of the sun. Now, how much is the time difference between local time of different longitudes? We just now learned that longitude helps us to determine the local time of a place. We also learned that the local time of all the places over the globe varies. We shall now calculate how much is the difference between local times of two consecutive longitudes. Well, we know that the earth rotates in 24 hours on its axis. So, one rotation is equal to 24 hours. Also, we know that there are 360 lines of longitudes. So, these markings shows that there are 360 lines of longitudes. So, we can also say that 360 degree of Earth's rotation takes 24 hours, or the Earth turns 360 degree in 24 hours. So, now let's check what will be the time of one rotation if we express the time in minutes. We know that 1 hour is equal to 60 minutes. So, how much will be 24 hours? Well, for that we need to multiply 24 by 60. So, we can also say that 360 degree of Earth's rotation is equal to 24 into 60 minutes. So this is the expression that we will have if we try to express 360 degree of Earth's rotation into minutes. So our Earth takes 24 into 60 minutes to rotate 360 degree. Thus, we find that to turn or rotate by 360 degree, the Earth takes this much time. So, how much time does our Earth will take to turn or rotate by 1 degree? Let's find out. So, 1 degree should be equal to this expression, that is total time by 360 degree, that is total degree of rotation. So total time taken of rotation is equal to 24 into 60 by total degree of Earth's rotation, that is equal to 360. Thus, 1 degree of Earth's rotation is equal to this expression. Now, if we solve this expression, then we will get the time that our Earth takes to turn or rotate by 1 degree. So, let's solve this expression. So, 1, 6 and 6 divided by 24. So, we get that 1 degree is equal to 4 minutes. Thus, we can say that the Earth takes 4 minutes to rotate by 1 degree, or 1 degree of Earth's rotation takes 4 minutes. Since we know that the longitudes are drawn at an interval of 1 degree, so the time difference between the two consecutive lines of longitudes will be 4 minutes. Now, before we proceed with our lesson, can you help me to answer this question? How much time is taken by the Earth to rotate by 1 degree? Is it 4 minutes, 15 minutes, 1 hour, or 24 hours? Yes, the correct answer is 4 minutes. The Earth takes 4 minutes to rotate by 1 degree. Just a while ago, we calculated that the time difference between two consecutive lines of longitudes is 4 minutes. So we understood that the time difference between two longitudes is 4 minutes. But how can we determine the local time of a place using longitudes? Let's see. We generally determine the time of other longitudes based on the time at prime meridian. So, if we shift 1 degree east to the prime meridian, then we add 4 minutes. Again, if we shift 1 degree further, then we again add 4 minutes. So, the longitudes lying to the east of prime meridian will have time 4 minutes ahead of prime meridian. So, if the local time at prime meridian is 12 noon, then this particular longitude, that is 1 degree east longitude, will have 4 minutes ahead of 12 noon, that is 4 minutes past 12 noon. Similarly, if we want to find out the time corresponding to this longitude, that is 2 degree east, then we will add 4 minutes to this time. Now what about the longitudes lying to the west of prime meridian? How do we calculate the time corresponding to these longitudes? That is, the longitudes lying to the west of prime meridian. To find out the time corresponding to the longitudes lying to the east of prime meridian, we add 4 minutes. Now, if we want to calculate the time lying to the west of prime meridian, then we don't add 4 minutes. Rather, we subtract 4 minutes. So, if the time corresponding to prime meridian is 12 noon, then the time corresponding to 1 degree west will be 12 noon minus 4, that is 11:56 am. Now if we move 1 degree west further, then again we will subtract 4 minutes from this time. So the time by 2 degree west longitude will be 11:52 am. Thus we understood that if we move to the east of prime meridian, then we keep on adding 4 minutes, and if we move to the west of prime meridian, then we keep on subtracting 4 minutes. So from this picture we can understand that places lying to the east of prime meridian or longitudes lying to the east of prime meridian will have time 4 minutes ahead of time corresponding to prime meridian. Similarly, longitudes lying to the west of prime meridian will have time 4 minutes behind the time corresponding to prime meridian. So if we move to the east of prime meridian, then we will add 4 minutes, and if we move to the west of prime meridian, then we will subtract 4 minutes. Now you must be wondering why we add 4 minutes if we move to the east of prime meridian, while we subtract 4 minutes if we move to the west. This is because our earth rotates from west to east. So the eastern hemisphere of our globe faces the sun first. So places lying to the east of 0 degree longitude will have time ahead to that of the prime meridian. Again, places lying to the west of prime meridian will have time behind the 0 degree longitude. This is because the western hemisphere sees the rising sun after the prime meridian. So this is how we can calculate the local time of different longitudes based on the prime meridian. In fact, the local time of different longitudes are determined based on the prime meridian. Since prime meridian is the basis of finding the time of other longitudes, or other longitudes are drawn with respect to the prime meridian, so all the lines of longitudes are also known as meridians. Also, the literal meaning of meridian is midday. You can relate this with the position of the sun corresponding to each line of longitude. We know if the sun is overhead over a particular longitude, then that longitude will have 12 noon or midday. So this is the reason why longitudes are also known as meridians, as they experience midday when the sun is overhead over that particular longitude. So I hope you understood the meaning of local time and how we can calculate the local time of different longitudes based on the prime meridian. Now we will solve different numericals to understand the different ways in which we can calculate the local time of a place. So this is our first numerical on calculating local time of a place. Here we have to find out the local time of 30° west longitude when it is noon at 0° meridian. So the time corresponding to prime meridian is 12 noon. We shall now find out the time corresponding to 30° west longitude. Well, we know that 1 degree of Earth's rotation takes 4 minutes. Now, this is the most important formula that we will apply for calculating local time of different places. So, 1 degree is equal to 4 minutes. So, 15 degree will be equal to how much? 15 into 4. So 15 into 4, which is equal to 60 minutes. Now we know that we can express 60 minutes as 1 hour. Thus, 15 degree of Earth's rotation will take 1 hour. Now, if a place is 30 degree away from the prime meridian, then the time difference of that place will be 1 hour into twice of this time. So, 1 hour into 2, which is equal to 2 hours. So, this longitude lying to the west of prime meridian will have 2 hours behind the prime meridian, because this particular longitude lies to the west of prime meridian. Now, if you remember, I already mentioned that the longitudes lying to the west of prime meridian will have time behind the prime meridian. So, the time corresponding to 30 degree west longitude will be 12 minus 2, which is equal to 10 AM. So, if the time at prime meridian is 12 noon, then the time corresponding to 30 degree west longitude will be 10 AM. So, we just computed that if the time corresponding to 0 degree prime meridian is 12 noon, then the time corresponding to 30 degree west longitude will be 10 AM. So, here we have the entire solution of this numerical. You can pause the video and have a look at the solution. So, here we calculated the time corresponding to a particular longitude when the time corresponding to the prime meridian is already given. We shall now see how we can calculate the local time of a longitude when the time corresponding to a different line of longitude is already given. Now, here we have two locations A and B. The longitude passing through location A is 40 degree west, and the time corresponding to this longitude is 5 PM. Again, the longitude passing through location B is 20 degree east, but we don't know the time corresponding to this longitude. So, we will now compute the time corresponding to 20 degree east longitude. So, here we know the time at 40 degree west is 5 PM. Now, here 5 p.m. is written according to 12-hour clock notation. Now if we express 5 p.m. in 24-hour clock notation, then we can write this as 17. So how did we get 17 hours? Well, to convert 12-hour clock notation to 24-hour clock notation, we have to add 12 hours with the given time. So if the time corresponding to 12-hour clock notation is 5 p.m., then the time corresponding to 24-hour clock notation will be 17 hours. And 12 hours is only added if the time in 12-hour clock notation is expressed in AM, then we don't add 12 hours. We only express the time in 24-hour notation by adding zeros. That is, if this time would have been 5 AM instead of PM, then according to 24-hour clock notation, it would have been 5.00. But here the time is 5 p.m. So 5 p.m. can also be written as 17 hours according to 24-hour clock notation. Now for finding out the time corresponding to 20 degree east longitude, we will first see the longitudinal difference between these two longitudes. The longitudinal difference between these two longitudes is equal to, there are 40 lines of longitude to the west of prime meridian or 0 degree. So 40 degree to the west, and there are 20 lines of longitudes to the east of 0 degree. So 20 in the east. So 40 degree plus 20 degree equals to 60 degree lines of longitudes is the difference between these two lines of longitudes. So this angular distance is equal to 60 degree. Now do you remember the most important formula? I mentioned that the most important formula for calculating any local time is, we must always remember 1 degree is equal to 4 minutes. So if 1 degree is equal to 4 minutes, then 60 degree will be equal to 60 into 4, which is equal to 240 minutes. So the time difference between these two lines of longitudes is 240 minutes. Now we know that we can also express 240 minutes as 4 hours. Well, for converting minutes into hours, we simply divide by 60, as 1 hour is equal to 60 minutes. So if we divide 240 by 60, we will get 4. So 240 minutes equals to 4 hours. So we understood that the time gap between these two longitudes is of 4 hours. Now should we add 4 hours or should we subtract 4 hours? Well, if you carefully look at the picture, then you will find that 20 degree east longitude is to the east of 40 degree west longitude. Now since this longitude is to the east of this given longitude, so we will add 4 hours, because places lying to the east always has time ahead of the places lying to the west. So the time corresponding to 20 degree east longitude will be given time, that is 5 p.m. or 17 hours plus 4 hours, which is equal to 21 hours. Now 21 hours equals to 9 p.m. So 21 hours is the time according to 24-hour notation, and 9 p.m. is the time according to 12-hour clock notation. So if the time corresponding to 40° west longitude is 5 p.m., then the time corresponding to 20° east longitude will be 9 p.m. That is 4 hours ahead of the time corresponding to this longitude. So this is the complete solution of the numerical. Now you can pause the video and have a look at this numerical. Now in this numerical, we had to find the time of a particular longitude when the time corresponding to a different longitude was already given. Now we will understand how we can calculate the longitude of a particular place when the time is already given. Now see, here we have two locations, X and Y. The longitude passing through location X is 50° west, and the time corresponding to this longitude is 5 p.m. Now we will have to find out the longitude passing through location Y, or the longitude whose time is 2 p.m. So what all information do we have here? We know that the time corresponding to location X is 5 p.m. or 17 hours according to 24-hour notation. Again, the time corresponding to location Y is 2 p.m. or how will you find out the 24-hour clock notation? Yes, you will simply add 12 to it, which is equal to 14 hours. So what is the difference between these two timings? The difference between these two timings is of 3 hours. Now let's convert 3 hours into minutes. For converting 3 hours into minutes, we will have to multiply 3 by 60, which is equal to 180 minutes. So the time difference between these two locations is of 3 hours or 180 minutes. Now we will apply the golden rule, that is 4 minutes is equal to 1 degree, or 1 degree of Earth's rotation is equal to 4 minutes. So if the Earth rotates 1 degree in 4 minutes, so if in 4 minutes the Earth turns by 1 degree, so in 180 minutes, the Earth will turn by how much degree? It will be equal to 180 by 4, which is equal to 45 degree. So the Earth will turn by 45 degree in 180 minutes. Or we can also say that if the time difference between these two locations is 180 minutes, then the longitudinal difference between these two places is 45 degree. Now you must be wondering that the longitude passing through location Y is 45 degree east of 50 degree or 45 degree west of 50 degree. Well, for this we need to note the time corresponding to this location. Just see that the time corresponding to location Y is 2 p.m. Now 2 p.m. is 3 hours behind 5 p.m. So this longitude passing through location Y must lie to the west of 50° west longitude. So the longitude of location Y will be 50° west plus 45° further west, which is equal to 95° west. So the longitude of location Y is 95° west, and the time corresponding to this longitude is 2 p.m. Now if we draw this longitude in this picture, then the longitude will lie to the west of 50° west longitude. So somewhere here. So this line will be 95° west, and the time corresponding to this longitude is already given, which is 2 p.m. And we also computed that the angular distance between these two longitudes is 45 degrees. This much is 45 degree. So the longitude passing through location Y is 95° west, and the time corresponding to this longitude is 2 p.m. So the entire solution of this numerical is given here. Now you can pause the video and have a careful look at this solution. So in today's video, we understood the meaning of local time. Local time is the time based on a longitude when the sun is overhead on that particular longitude. When the sun is overhead on a particular longitude, the local time of that longitude is 12 noon. Then we understood that the difference between local time of two consecutive longitudes is 4 minutes. Then we also understood how we can calculate the local time of different longitudes based on the prime meridian. If the longitude lies to the east of prime meridian, then we add 4 minutes. If the longitude lies to the west of prime meridian, then we subtract 4 minutes. Then we solve different numericals related to local time. For solving the numericals related to local time, you must remember two golden rules. 1 degree of Earth's rotation is equal to 4 minutes, and if the longitude lies to the east of a specific longitude, then you will add the time difference. If the longitude lies to the west of a specific longitude, then you will subtract the time difference. In our next video, we will understand the meaning of time zones. Don't forget to subscribe to our channel and hit the bell icon. You can also register for free at DeltaStep.com or download the DeltaStep app to learn one-to-one with our amazing teachers, or to get access to our 5,000 amazing videos as per your school syllabus. Master each topic with our adaptive practice technology. Get million-plus questions with step-by-step solutions and unlimited mock tests. Get all your doubt resolved instantly. Learn via games and win amazing prizes like PlayStations and iPads. So at DeltaStep, learning is not just fun and easy, but it's rewarding too. So register for free now.